All right, so here's the goal. Here's the project over time that I've been trying to work on. It's a solar, all right? So forgive the crude nature here, but I have a solar array, I guess you'd call it. Um, and each one of those cells are approximately 1.5 volts optimal, right? So that'll give me 6 volts coming in. It's set on the platform, right? Yay, right? And so this platform will connect ever so crudely to this platform. Now that's a servo motor, right? And so that servo is going to chase the sun, right? So I have, which I didn't pull out, probably should have been a little better prepared for this, but essentially I have a little resistor. It's a photoresistor. It's about this big, and I've got a couple of them, right? This is actually a capacitor, but I have a couple of photoresistors about this big, and they're going to essentially control voltage, which will, they'll be placed, on either side essentially, and they'll control voltage to either left or right panning of the servo, right? So the goal is to, obviously generate power or store energy, right? So the initial brain is going to be this microcontroller here, right? Eventually, I hope to be able to remove the microcontroller altogether by way of programming IC chips. Right? Let's see if I can get these open without spilling them. Right. So I have a metric fuck ton of different types of chips. So I'll be able to find a programmable chip that can handle essentially side to side motion. That chip will replace this microcontroller unit. Now, as the power comes in, obviously I have, 6 volts coming in. I took this laptop battery apart. Now, don't ever, ever take one of these apart unless you're stupid like me. Because if you rupture one of these cells here, you will have a violent reaction. And you could seriously, seriously injure yourself, cause fire. This is no joke. Do not. I'm an idiot. Don't do what I do. Do safe stuff. I'm not a safe guy. Do safe stuff. Like I have the option to be safe, right? Because I'm half smart. And so, like, I have, box full of like rechargeable batteries that are nice and safe and whatnot, right? Even down to the rechargeable button batteries and whatnot, right? But no, not me. Why? Because I am, I'm designing for space and weight of the overall project, right? So anyway, it's all safety nonsense. All safety precautions set aside. The IC chip will mount, to something like this. That's nice and light. And so my initial power regulator, right, is here. So as the energy comes in to the system, right, it will be stabilized by this unit here. And then I'll have a stable power output, or should have a stable power output, to go to my batteries. Now, each of these battery cells, now this overall is a 15-volt battery series, but I'm going to separate these batteries, and so it'll be a 3 point, I don't know what it is, 3.5 something or whatever. But each one of these will charge, and when they reach their charging capacity, I hope to by then have researched a collapsing circuit, or whatever you want to call it, at some point, which will shut down the charging on the primary battery and then switch over charging to the secondary, etc., etc. So I will have a completely charged battery bank at 3 point whatever volts a piece, and then my output from here, from the batteries, will step up again, but I want to hold it at 12 volts. So I'll regulate again the power output back to a 12 volt, which then I can essentially break back down to be like my lab, which is here, which I broke down from the computer power, the tower power block. So I have my 12 volt, my 5 volt, and my 3 volt, and then my 12 volt negative and my 5 volt negative, which I don't even know why I wired those up. They are just not usable at my level. But maybe someday I'll learn how to electrocute myself with those. But yeah, this is kind of what I'm doing. And so the overall purpose of learning this stuff here is that I want to get my, I'm hoping to get my grow systems company back online, my agricultural grow systems company back up online. And I want to work on automation. So I have other components or microcontrollers that I'm studying that will help to, I don't know, I guess they call it the Internet of Things, help to run the Internet of Things. So like home automation, come in the house, tell it to turn on your water and run your shower and all that stuff. We can do that now. So I want to integrate that type of technology into the grow systems, the greenhouse, temperature control, air input control, water, etc. And all of this can be done by voice recognition, especially now if we input AI. And so on top of that, one of the components that we utilized back in the day, or wanted to utilize in depth, was tying in like perch or tilapia or edible fish into the grow system modules, right? So I've been learning how to raise fish tanks, right? Forgive the I'm into skulls. I'm sorry if it's offensive to you. Well, bite me because I like them. But anyway, this tank is crystal clear and has not had even a 5% water change in the last 4 months. So I'm definitely learning the water chemistry on a short scale. But now this monster here, so that's 20 gallons over there. I've got 40 gallons here, obviously a difference. It's not dirty water. I've cleaned this, and if the water's fine and I've tested it and it's fine, It's cloudy. I got a little ahead of myself in adding the fish, so my water chemistry is just a little off. But the environment overall is healthy. The fish are healthy. Nobody's dying. So it's just I got to get the water to clear up. And I think what had happened is I had reached a tipping point on my other tank where the substrate combined with the plants, right, and the microbiology that's happening in there, it just kind of flipped a switch and started to self-regulate. And so I did a ton of research. Don't worry, these guys are all safe. I did a ton of research though, and I'm in the process of fixing the water chemistry here, okay, to get that together. And then my next trick is going to be to get a 50 or maybe 70 gallon tank and really take my time. And I want to get perch fingerlings, right, baby perch, because my family eats perch. I don't eat fish, but my family, they love the things. So I'll grow them here and learn to utilize the water that's been converted through a natural process to fertilize the grow systems for vegetation. So I've got this, I've got to break out the old lighting and all of that stuff, et cetera, et cetera. But anyway, that's kind of where I am now and what I'm trying to do. I am open to suggestions. If anybody out there has worked on anything like this before, has any links to any information that pertains to what I'm trying to do, or some beginner to intermediate study guides that would continue to point me in the right direction. I'm doing a ton of research trying to find information on all of this stuff. And there are so many different types of microcontrollers that by the time you think you bought the right setup, you need to buy something else to get them to communicate right and stuff like that. And it's absolute insanity. So any insight would be greatly appreciated, because I'm using the Arduino, but then I came across this I guess these are MicroPython, the ESP32 microcontroller, right? And that's just on a programming board. It actually shows it actually kind of comes apart here, right? It's got these pins on the back and plugs right into those slots here. It's got power and data transfer. This bad baby here's got Wi-Fi and Bluetooth, right? So these things are really super cool. I can do Wi-Fi connectivity with my Arduino and stuff like that too, but these smaller microchips or microprocessors are fascinating. And then you got separate power converters. So really, really cool stuff. But anyway, anybody has any suggestions, tips, tricks, experience, anything like that, and can point me down a rabbit hole that is going to allow me to maintain some semblance of my sanity, I will be in your debt. Thank you for taking the time to kind of listen to me ramble on about what I'm trying to do, and enjoy your holidays.